Unit 23, Gateway. There has been a lot of discussion on why moths are attracted to light. The consensus seems to hold that moths are not so much attracted to lights as they are trapped by them. The light becomes a sensory overload that disorients the insects and sends them into a holding pattern. A hypothesis called the Mach band theory suggests that moths see a dark area around a light source and head for it to escape the light. Another theory suggests that moths perceive the light coming from a source as a diffuse halo with a dark spot in the center. The moths, attempting to escape the light, fly toward that imagined portal, bringing them closer to the source. As they approach the light, their reference point changes and they circle the light hopelessly, trying to reach the portal. Everyone is familiar with moths circling their porch lights. Their flight appears to have no purpose, but they are, it is believed, trying to escape the pull of the light. Exercises. Number 1. There is a problem from biology called the paradox of enrichment. Intuitively, one would think that a population of predators would tend to do better if the amount of food available to its prey were to increase. More food for the prey means that more prey is available to the predator, and hence the predator's population should expand as well. Yet in fact, sometimes the opposite happens. An increase in the food available to rabbits, for example, in a given area might lead to an overabundance of rabbits and increase the population of its predator, say wolves, until the population of wolves becomes unsustainably large and is destabilized. So, more food for the rabbits can actually pose a threat to the population of wolves. So, more food for the rabbits can actually pose a threat to the population of wolves. This example shows that our ordinary intuition that more food and hence more prey is always good for a predatory group is flawed. More is not always more, at least in the case of predators and prey. The paradox of enrichment shows that our intuitions about abundance and enrichment do not always conform to observable facts. Number 2. Our planet is about 4.6 billion years old. Much of the Sahara is underlain by rocks that date back to between 2.5 billion and 500 million years ago. These rocks have been greatly altered by extreme heat and pressure, and have long been known by the very general term basement complex. The basement complex rocks have undergone periodic intervals of uplift and deformation, followed by intervals of prolonged erosion. They are overlain by more or less undeformed sedimentary rocks that were laid down by water, wind, and ice. This sedimentary cover is up to 10 kilometers thick and occupies well over half of the present Sahara. As a result, basement complex rocks are only visible at the surface of the Sahara in about 15% of its total area. The contact between basement complex and sedimentary cover is often very sharp and is sometimes evident as a line of springs, some still active, some long dry. Number 3. The drive toward equilibrium, a minimum energy state where there is no further tendency to change, is one of the fundamental principles of chemistry and physics. Falling objects come to rest at the lowest energy state. Chemical reactions proceed to completion, where no further reaction occurs. While this driving force is manifest everywhere, natural systems, even when they are at a steady state, are usually far from equilibrium. At equilibrium, properties such as temperature and pressure are constant throughout the system, and the system is isolated from external influences. That is not the natural world. One of the benefits of laboratory experiences is that when we actually try to measure properties at equilibrium, it becomes evident that controlling the conditions for such perfection to appear is very difficult indeed. Natural systems are not isolated. Matter flows in and out. Properties such as temperature and pressure change continuously. Natural phenomena do not exist in static equilibrium states, but are in movement at all scales.